Chapter 4. Externalized Configuration Management. This chapter covers configuring Spring with properties and profiles, applying external configuration with Spring Boot, implementing a configuration server with Spring Cloud Config Server, configuring applications with Spring Cloud Config Client. In the previous chapter, we built a RESTful application for managing a catalog of books. As part of the implementation, we defined some data to configure certain aspects of the application in an application.yml file, such as the Tomcat thread pool and connection timeout. The next step might be to deploy the application to different environments, first in a test environment, then staging, and finally in production. What if you needed a different Tomcat configuration for each of these environments? How would you achieve that? Traditional applications were usually packaged as a bundle, including the source code and a series of configuration files containing data for different environments, with the appropriate configuration being selected through a flag at runtime. The implication was that you had to make a new application build every time you needed to update the configuration data for a specific environment. A variant of this process was to create a different build for each environment, meaning that you had no guarantee whether what you ran in a staging environment would work the same way in production because they were different artifacts. Configuration is defined as everything likely to change between deployments, as per the 15-factor methodology, like credentials, resource handles, and URLs to backing services. An application deployed in multiple locations will likely have different needs in each location and require different configurations. A key aspect of cloud-native applications is that the application artifact will stay immutable across environments. No matter which environment you deploy it to, the application build will not be changed. Each release you deploy is a combination of build and configuration. The same build can be deployed to different environments with different configuration data, as shown in Figure 4.1.
Figure 4.1. Each release you deploy is a combination of build and configuration, which is different for each environment.
Anything that might need to change across deployments should be configurable. For example, you'll probably want to change feature flags, credentials for accessing backing services, resource handles for databases, or URLs to external APIs, all depending on the environment to which you're deploying the application. Cloud-native applications favor externalized configuration so that you can replace it without having to rebuild your code. Regarding credentials, it's even more critical not to store them with your application code. There have been countless data breaches because of companies including credentials in a repository that went public by accident. Make sure you won't be one of them. In Spring, configuration data is abstracted as properties, key value pairs, defined in different sources such as property files, JVM system properties, and system environment variables. This chapter covers various aspects of configuring Spring applications that are relevant in a cloud-native context. I'll first present the main concepts behind how Spring handles configuration, including properties and profiles, and how you can apply externalized configuration with Spring Boot. Then I'll show you how to set up a configuration server with Spring Cloud Config Server, using a Git repository as the backend for storing your configuration data. Finally, you'll learn how to use the config server to configure a Spring Boot application by relying on Spring Cloud Config Client. By the end of this chapter, you'll be able to configure your cloud-native Spring applications in different ways, depending on your needs and the type of configuration data you have. Table 4.1 summarizes the three main strategies for defining configuration data for cloud-native applications covered in this chapter. Chapter 14 will further extend the subjects covered here, including secrets management and how to use config maps and secrets in Kubernetes. Note: the source code for the examples in this chapter is available in the Chapter 04/04 Begin and Chapter 04/04 End folders, which contain the initial and final states of the project. See this link.
Table 4.1. Cloud-native applications can be configured according to different strategies. You will likely use them all, depending on the type of configuration data and the application requirements. View table figure.
Section 4.1, Configuration in Spring, Properties and Profiles. The term configuration can have different meanings depending on the context. When discussing the Spring Framework's core features and its application context, configuration refers to which beans, Java objects registered in Spring, have been defined to be managed by the Spring container and are injected where needed. For example, you can define beans in an XML file, XML configuration, in a configuration class, Java configuration, or by relying on annotations like component, annotation-driven configuration. In this book, unless specified otherwise, whenever I mention configuration, I don't mean the previous concept, but rather everything that's likely to change between deployments as defined by the 15-factor methodology. Spring provides you with a convenient environment abstraction that gives you access to any configuration data, no matter its source. The two key aspects of a Spring application environment are properties and profiles. You have already worked with properties in the previous chapter. Profiles are a tool for labeling logical groups of beans or configuration data that should be loaded at runtime only if a given profile is enabled. Figure 4.2 shows the main aspects of a Spring application environment.
Figure 4.2. The environment interface gives access to the two key aspects of any Spring application configuration: properties and profiles.
This section will cover the fundamental aspects of properties and profiles for cloud-native applications, including how to define custom properties and when to use profiles. Section 4.1.1, Properties, Key Value Pairs for Configuration. Properties are key value pairs supported in Java as first-class citizens with java.util properties. They play an essential role in many applications for storing configuration parameters outside of the compiled Java code. Spring Boot automatically loads them from different sources. When the same property is defined in multiple sources, there are rules that determine which one takes precedence. For example, if you specify a value for the server.port property both in a property file and a command line argument, the latter takes precedence over the former. The following is a prioritized list of some of the most common property sources, starting with the highest priority. 1. Test property source annotations on test classes. 2. Command line arguments. 3. JVM system properties from system.getProperties. 4. OS environment variables from system.getEnv. 5. Configuration data files. 6. Property source annotations on configuration classes. 7. Default properties from Spring application.setDefaultProperties. For the complete list, you can refer to the Spring Boot documentation. See this link. Configuration data files can be further prioritized, starting with the highest priority. 1. Profile-specific application properties from applicationprofile.properties and applicationprofile.yml files packaged outside your jar. 2. Application properties from application.properties and application.yml files packaged outside your jar. 3. Profile-specific application properties from application.profile.properties and application.profile.yml files packaged inside your jar. 4. Application properties from application.properties and application.yml files packaged inside your jar. The beauty of property handling in Spring is that you don't need to know the specific property source to get a value. The environment abstraction lets you access any property defined in any source through a unified interface. And if the same property is defined in multiple sources, it returns the one with the highest priority. You can even add your own custom sources and assign a priority to them. Note: Spring Framework has built-in support for properties defined according to the properties format. On top of that, Spring Boot adds support for defining properties using the YAML format. YAML is a superset of JSON that provides more flexibility than the simpler properties format. The official website describes YAML as a human-friendly data serialization language for all programming languages, yaml.org. Feel free to choose either approach in your applications. All the examples in the book will use YAML. Using application properties. There are a few ways to access properties from a Java class, as shown in Figure 4.3. The most generic approach is based on the environment interface, which you can auto-wire wherever you need access to an application property. For example, you can use it to access the value for the server.port property as follows.
See this code? Figure 4.3. You can access Spring properties in different ways.
Properties can also be injected without explicitly invoking the environment object. Just like you use the auto-wired annotation for injecting Spring beans, you can apply the value annotation to inject property values.
See this code?
You can configure the application using properties without hard-coding values inside the code, which is one of our goals. But when using the environment object or the value annotation, you still have a hard-coded value that can become difficult to manage, the property key. A more robust and maintainable option, which is also the one recommended by the Spring team, is to use special beans marked with the configuration properties annotation to hold configuration data. We'll explore this feature in the next section while you learn how to define custom properties. Defining custom properties. Spring Boot comes bundled with tons of properties for configuring any aspect of your application, depending on which starter dependency you import into your project. Sooner or later, though, you'll find you need to define your own properties. Let's consider the catalog service application we have been working on. In Chapter 2, we defined an HTTP endpoint that returned a welcome message to users. We now have a new requirement to implement. The welcome message should be configurable. This is probably not the most useful functionality, but it will help me illustrate the different configuration options. The first thing to do is tell Spring Boot to scan the application context for configuration data beans. We can do so by adding the configuration properties scan annotation to the catalog service application class in your catalog service project, catalog service.
Listing 4.1. Enabling scanning of configuration data beans.
Note: instead of making Spring scan the application context, searching for configuration data beans, you can directly specify which ones Spring should consider by using the Enable Configuration Properties annotation. Next, you can define a new com.polarbookshop.catalogservice.config package and create a Polar Properties class annotated with configuration properties to mark it as a holder of configuration data. The configuration properties annotation takes a prefix argument combined with a field name to produce the final property key. Spring Boot will try to map all properties with that prefix to fields in the class. In this case, there's only one property mapped to the bean, polar.greeting. Optionally, you can add a description for each property using Java comments that can be converted into metadata, as I'll show you in a minute.
Listing 4.2. Defining custom properties in a Spring bean.
Optionally, you can add a new dependency on the Spring Boot configuration processor in your build.gradle file. That will automatically generate metadata for the new properties and store them in meta-inf/spring configuration metadata.json when building the project. The IDE can pick them up, show you the description message for each property, and help you with auto-completion and type checks. Remember to refresh or re-import the Gradle dependencies after the new addition.
Listing 4.3. Adding dependency for the Spring Boot configuration processor.
Now you can trigger the metadata generation by building your project ./Gradle w clean build. At this point, you can go ahead and define a default value for the polar.greeting property in the application.yml file. While you are inserting the new property, your IDE should provide you with an auto-completion option and type check, as shown in Figure 4.4.
Listing 4.4. Defining a value for a custom property in catalog service. Figure 4.4. Using the Spring Boot configuration processor, the Java.comment from your custom property bean is converted into metadata that's used by your IDE to provide useful information, auto-completion, and a type check.
In Listing 4.2, the greeting field will be mapped to the polar.greeting property, for which you have just defined a value in application.yml. Using custom properties. Classes or records annotated with configuration properties are standard Spring beans, so you can inject them wherever you need them. Spring Boot initializes all the configuration beans at startup and populates them with the data provided through any of the supported configuration data sources. In the case of catalog service, the data will be populated from the application.yml file. The new requirement for catalog service is to make the welcome message returned by the root endpoint configurable via the polar.greeting property. Open the Home Controller class and update the handler method to get the message from the custom property instead of using a fixed value.
Listing 4.5. Using custom properties from a configuration properties bean.
You can now build and run the application to verify that it works as intended. /gradle w boot run. Then open a terminal window and send a GET request to the root endpoint exposed by catalog service. The result should be the message you configured in application.yml for the polar.greeting property.
See this code?
Note: property files packaged with your application code are useful for defining sensible default values for your configuration data. They can also act as specifications for what configuration properties your application supports. The following section will cover the other key aspect modeled by the Spring Environment Abstraction, profiles, and how to use them for cloud-native applications. Before moving on, you can stop the application with Control-C. Section 4.1.2, Profiles, Feature Flags, and Configuration Groups. Sometimes you might want to load a bean into the Spring context only under specific conditions. For example, you might want to define a bean responsible for generating test data only when you're working locally or testing the application. Profiles are logical groups of beans that are loaded into the Spring context only if the specified profile is active. Spring Boot also extends this concept to property files, allowing you to define groups of configuration data that are loaded only if a specific profile is active. You can activate 0, 1, or more profiles at a time. All beans not assigned to a profile will always be activated. Beans assigned to the default profile are only activated when no other profile is active. This section presents Spring profiles in the context of two different use cases: feature flags and configuration groups. Using profiles as feature flags. The first use case for profiles is for loading groups of beans only if a specified profile is active. The deployment environment shouldn't influence the reasoning behind the groupings too much. A common mistake is using profiles like dev or prod to load beans conditionally. If you do that, the application will be coupled to the environment, which is usually not what we want for a cloud-native application. Consider the case where you deploy applications to 3 different environments, development, test, and production, and define 3 profiles to load certain beans conditionally, dev, test, and prod. At some point you decide to add a staging environment, where you also want to enable the beans marked with the prod profile. What do? You have 2 options. Either you activate the prod profile in the staging environment, which doesn't make much sense, or you update the source code to add a staging profile and assign it to the beans marked as prod, which prevents your application from being immutable and deployable to any environment without any change to the source code. Instead, I recommend using profiles as feature flags when they're associated with groups of beans to be loaded conditionally. Consider what functionality a profile provides and name it accordingly, rather than thinking about where it will be enabled. You might still have cases where a bean that handles infrastructural concerns is required in specific platforms. For example, you might have certain beans that should only be loaded when the application is deployed to a Kubernetes environment, no matter whether it is for staging or production. In that case, you could define a Kubernetes profile. In Chapter 3, we built the catalog service application to manage books. Whenever you run it locally, there are no books in the catalog yet, and you need to add some explicitly if you want to work with the application. A better option would be to let the application generate some test data at startup, but only when it's needed, for example, in a development or test environment. Loading test data can be modeled as a feature that you enable or disable through configuration. You could define a test data profile to toggle the loading of this test data. In that way, you'll keep the profiles independent from the deployment environment, and you can use them as feature flags with no constraint on the deployment environment whatsoever. Let's do that. First, add a new com.polarbookshop.catalogservice.demo package to your catalog service project and create a book data loader class. You can instruct Spring to load this class only when the test data profile is active by applying the profile annotation. Then you can use the book repository we implemented in Chapter 3 to save the data. Finally, the event listener, application-ready-event.class. Annotation will trigger the test data generation after the application has completed the startup phase.
Listing 4.6. Loading book test data when the test data profile is active.
In your development environment, you can use the spring.profiles.active property to set the test data profile as active. You could set it in the application.yml file for the catalog service project, but it's not ideal to have the test data feature enabled by default. What if you forget to overwrite it in production? A better option is configuring it specifically for the local development environment when running the boot run task. You can achieve that by adding the following code to the build.gradle file.
Listing 4.7. Defining the active profiles for the development environment.
Let's verify that it works. Build and run the application, /gradle w boot run. You'll see a message in the application logs listing all the active profiles. In this case, it's just test data, but there can be more, as shown in Figure 4.5.
Figure 4.5. The logs for catalog service when the test data profile is active.
Then you can send a request to the application to fetch all the books in the catalog.
See this code.
It should return the test data we created in Listing 4.6. When you're done, stop the application with Ctrl+C. Note: instead of using profiles as feature flags, a more scalable and structured approach is defining custom properties to configure functionality and relying on annotations such as conditional on property and conditional on cloud platform to control when certain beans should be loaded into the Spring application context. That's one of the foundations of Spring Boot auto configuration. For example, you could define a polar.testdata.enabled custom property and use the conditional on property, name equals polar.testdata, enabled, having value equals true, annotation on the book data loader class. Next, I'll show you how to use profiles to group configuration data. Using profiles as configuration groups. The Spring Framework's profile functionality allows you to register some beans only if a given profile is active. Likewise, Spring Boot lets you define configuration data that is loaded only when a specific profile is active. A common way to do that is inside a property file named with the profile as a suffix. In the case of the catalog service, you could create a new application.dev.yml file and define a value for the polar.greeting property, which would be used by Spring Boot only if the dev profile was active. Profile-specific property files take precedence over the non-specific property files, so the value defined in application.dev.yml would take precedence over the one in application.yml. In the context of property files, profiles are used to group configuration data, and they can be mapped to deployment environments without facing the same issues we analyzed in the previous section when using profiles as feature flags. But that applies only as long as you don't package the profile-specific property files with the application. The 15-factor methodology recommends not batching configuration values into groups named after environments and bundled with the application source code because it wouldn't scale. As a project grows, new environments might be created for different stages. Developers might create their own custom environments to try out new functionality. You can quickly end up with way too many configuration groups, implemented like Spring profiles and requiring new builds. Instead, you'll want to keep them outside the application, such as in a dedicated repository served by a configuration server, as you'll see later in this chapter. The only exception is for defaults and development-oriented configuration. The following section will cover how Spring Boot addresses externalized configuration. You'll learn how to use command line arguments, JVM system properties, and environment variables to provide configuration data from the outside while using the same application build.